Hello, in this video we're going to talk about the beginning steps of learning target 231, which is to graph quadratics. So we're going to talk about two ways to do that, and in order to graph quadratics we need at least 3 points, and these points specifically need to be centered around the vertex. So in order to graph, we're going to talk about the characteristics method and then the table method. Now, the characteristics method uses what you already know, which is all the characteristics of quadratics. So in order to use this method to graph, you would have to find all of your characteristics, which includes your directionality, your line of symmetry, your vertex, your y-intercept, and your x-intercepts. So that's a lot of things, and each of these has their own method for finding them, so it takes quite a long time. If you can imagine even just spending 1 minute on each of these, you would spend 5 full minutes finding the characteristics before you could even use them to actually graph. So this method is quite time consuming, and then if you're missing any of the characteristics, so for example, if you don't have any x-intercepts, or your y-intercept is really large, like 3,000, that would be really hard to graph. And so using the characteristics method sometimes works, but often it's not going to be our best choice. The only time I'd say to use your characteristics to graph is if you already had to find them. So for some reason, if you already found all of this for a quadratic, and then you are asked to graph it, then you can just use these, put those on a graph, and graph. For the table method, this helps us take less time, and it works no matter where your quadratic is on the graph, whether it's very large or small or anything in between. So the table method starts by finding the vertex. And there are two ways that we can do that. The first way is what you already know, which is when we have our quadratic in standard form. You can use our line of symmetry formula to find your x, and then plug x in to find your y. So this is kind of what we've been doing. Now there's also something called vertex form, which looks like this. And this is just another way that I could give you a quadratic function. And in this way, finding the vertex is actually very easy because the vertex is h comma k. And because the vertex is easily seen in the quadratic, this is actually called vertex form. The only thing that you really need to be careful about is that h is always the opposite of what it is in the function. So because that minus sign, h is going to be the opposite, so we need to make h the opposite sign. So then as this method suggests, we're going to make a table from these values. And I'm basically trying to find some points around the vertex so I can see my parabola start to take shape. So after we do this, then we are going to make the table. And our table should look something like this. We have our x and our y. And then I'm going to ask you to do 5 points every time you make the table. Your very center will be your vertex, and then you will build the rest of the table around your vertex. So whatever you get for your vertex goes here, and then you make the smaller points and the larger points around this one. So now let's look at how to identify the vertex. So you need to be able to find the vertex in both standard and vertex form. So if you see parentheses like these 3, these are going to indicate vertex form. which means to find my vertex, all I need to do is identify H, which is inside the parentheses, and K, which is outside at the end. So they're always in the same spots. H inside the parentheses, K at the end by itself. And then all I need to do is flip the sign for H. So my vertex for this one is just -7, -9. So you flip H, leave K the same, and this is your vertex. Pretty simple. And you can do the same thing for this, both of these ones with stars. Why don't you go ahead and pause this video and do those two, and then we'll come back and talk about the others. So notice for this one, I have my H, which is, I'm going to flip to be a +8, and then K doesn't exist. There's nothing after the parentheses, so that means it's 0. Over here, flip your H to be a +2, and then K is also a +2. And then if it's not in vertex form, you have to use that formula. So for these two, for example, we're going to use the formula -b/2a. We're going to plug in our values, and then we'll take this x and plug it back in to find our y. I want you to pause the video and do these two on your own, and then I want to talk about this last one after you're done. All right, so I have my answers on here. So I plugged in my values, and for this first one, I get +5 and then +18. So that's my vertex. And then for the second one, when I plug in my values to the formula, I get -1.5. When I plug that in, I get -16.75. I have my work there if you need to pause and look at it closer to see if you made any errors, if you can identify your mistakes. This last one I wanted to save until the end because it does not have parentheses, so that indicates to do this method where we have to actually use the formula and plug it in. Now you can do that. So if I do that, I get -b, but my b value is missing, so -0 over 2 times a, which is 1. 0 divided by anything is just 0, so that's my x value. And then to find my y value, I just need to plug this 0 in. So I get 0 squared plus 12, which equals 12. So my vertex is 0, 12. The other thing I wanted to point out, though, is even though this doesn't have parentheses, you can see that this is where your h is supposed to go with this x. And there's nothing there, so it's really like x plus 0, so our h is 0. And then our k, which is our constant, is at the end by itself, which is just that 12. So for this one in particular, you could do either method. That happens when b is missing. So if b is missing, you can do either vertex form or the formula. And this is actually where we are going to stop for today. I know there's a backside, but we are going to wait and finish that in the next class period. Thanks, everyone.